So let's see how all of our four basic operations relate to each other. So we have addition, subtraction, multiplication, and division that we've looked at. We learned that addition and subtraction are inverses of each other. That's the reason I can do fact families with them. I can rewrite addition problems as subtraction, subtraction as addition. And the same is true for multiplication and division. We saw that we can rewrite them, division as multiplication, and we also have fact families for those. We also know that repeated addition is multiplication, and we saw today that repeated subtraction is division. Now do notice that the red arrows only go one way. If I have repeated multiplication, that is not addition. In fact, we haven't seen it yet, but we will see it later this section. I've got exponents. Whenever I have to repeat multiplication, those become exponents. There is one other thing down here. Exponents are repeated multiplication, and we'll get to that in a little bit. We don't have to worry about repeated division. The farthest we're going to have to get is to some exponents here. But those, we cannot go the opposite way. We can't say repeated division is subtraction, but we can on those black arrows kind of go both ways. It doesn't matter if we start with division or multiplication. We can rewrite a problem and end up with the other operation. Let's look at some algorithms here. So the algorithms, these are basically, there's not a whole bunch for division. We've got to do everyone's probably least favorite thing, which is long division. So I'm going to start us with a problem that does not have a remainder. Now I like to write down these steps that I'm going to be doing. And I remember them like a family. There's a dad, a mom, a sister, and brother. And they stand for divide, multiply, subtract, and bring down. But I remember dad, mom, sister, brother to help me remember that order. So I'm going to start with my first ones place. 7 divided by 5 is 1. That's the division step. Then I'm going to multiply. 1 times 5 is 5. That's the multiplication. I'm going to subtract. 7 minus 5 is 2. Oops. And then I'm going to bring down a 2. And then I'm going to do the same thing all over again. 22 divided by 5 is 4. That was my divide. 4 times 5 is 20. I'm going to subtract to get 2. And then I'm going to bring down to get 5. Again, 25 divided by 5 is 5. 5 times 5, don't have a lot of room, is 25. And when I subtract, I get that 0. I don't have any numbers up here. And I've got a 0 down, so that means I've got my answer to be 145. Feel free to watch this as many times as you need to refresh yourself on long division. You also can go to YouTube and watch videos on how to long divide. There's plenty of them out there of parents trying to help their kids learn long division. So there's lots of resources if you need some extra support with that. Let's do one more problem with this long division though. This one does have a remainder. So why don't you pause it and see if you can get this answer. I know you can type these in your calculator and kind of give a check. That's completely fine. With the remainders, it's a little bit harder to see with the decimals, and we don't have decimals yet in our class. So we are just going to write it as a remainder. Let's see if you can pause and go ahead and get this answer. All right, let's see how you did. 4 divided by 4 is 1. 1 times 4 is 4. I'm going to subtract and bring down. 9 divided by 4 is 2. 2 times 4 is 8. I'm going to subtract and bring down. Let it finish saving. I can bring it down. 13 divided by 4 is 3. 3 times 4 is 12. and I have a remainder of 1. I finished my numbers up here. I'm not going to continue to add on. I'm not going to do decimals. I'm not going to write this as a fraction. I don't have those number sets yet. All we have right now are whole numbers. So my answer would be 123 with a remainder of 1.